So we're going to hear now, and we're going to learn about layer 2s. So the stage is yours, my friend.
Great, thank you. So yeah, I'm going to touch upon the merge a bit later, but to get started, just tell you a bit about who I am. I sort of summarize it as, in the 80s I grew up and installed and played DOS games. Then I learned QBasic, sort of taught myself to code in the 90s. In the noughties, studied engineering, computer science, and wrote software for hardware. So basically doing products, physical products, as well as sort of pre-mobile things. Then, in 2010s, wrote software for smartphones, later smart contracts. So I worked in a lot of product roles for app development, so a lot of startups there. So my eyes often towards products. So that's where my focus is now. I'm looking at the attributes of Web3 and how can they be applied to new and existing products in meaningful ways. So I'm currently working for the Ethereum Foundation under the Privacy and Scaling Explorations Group. And that's the project I'm on is called BLS Wallet. That's one of several projects on privacy and scaling. And that's not the core protocol work that I'm doing, so just a disclaimer there. The bit of format, I'm going to have a background around layers and rollups, just to put that in context. And then touch upon the improvement that I'm working on for layer 2s, which is part of a PSC project. And then describe a bit about the merge and some information there. So let's just quickly peel back the layers. I'm conscious of time, given where we're at. So layer 0 can affectionately be known as people. They sort of, on top of that, people use a blockchain. Layer 1 blockchains exist. There's a lot of them out there. The layer 2, so once a layer 1 sort of hits capacity, you want to then get some scaling, so layer 2s then make sense, and that's where that is. Alongside layer 1s, I'll say there's side chains. So there's between all of those things, there's different ways that they connect. So between people and blockchains, you've got Web 2.5 companies that will bridge the gap, the usability gap. So you have websites that feel like Web 2, but they're actually using Web 3 under the hood. So that's described as Web 2.5. There's individual dApps and wallets for people. But between sidechains and blockchains, there's bridges. So and similarly, between layer 2s and layer 1s, there's a rollup bridge. So there's just a bit of a difference between that because we know some bridges are not so secure. So similar to what someone said in the previous talk, or in another talk, chain is only as strong as its weakest link. So let's start with layer 1, the Ethereum blockchain. I look at it as a large secure store of value. So I try to find other terms to describe Ethereum or layer 1 blockchain like Ethereum. A blockchain is non-monopolistic, so that ties into trustlessness and it being decentralized. It's resilient, so it's censorship resistant, but also you have individuals who have aligned incentives working together on it. And similar with longevity. If you've got independent developers working towards those shared goals, they're building a shared infrastructure. So there's just a higher likelihood of that persisting without any centralized control. So those things are sort of necessary to have this strength, if you will, of the network to secure such a large amount of funds and not be hacked. But as we know, with great demand comes great gas fees. So I like using this graph just to show what sort of happens when your block size is limited. You can only have so many transactions per second, but there's a strong demand for Ethereum. So the price, of course, goes up during those times. The chart you see underneath that it's hard to read from here, but it's the top blockchains based on cumulative total revenue in the past 90 days. So these are people who are basically providing, processing transactions, they're mining blocks. On Ethereum, it has 314 million in revenue for those people securing that network. Whereas other networks are, relatively small. Binance Smart Chain's the next one, about 20% of that, and so on. You've got L2s are here. You've got Arbitrum here, Solana, Cardano, Polkadot is down there. But yeah, that's just sort of for me is based on utility. You see, what is the demand for which networks, and which networks sort of are pushing the price up and actually giving revenue to those who are securing the network. So that's just an interesting way to look at it. So when a network does have the demand and it gets pushed to that point of being too expensive, we saw, of course, other L1s formed, but there are other solutions to get the security of something as large like Ethereum with the transaction speed. So that's where layer 2 scaling solutions come in. Specifically, I'll talk about rollups. So as we know with rollups, transactions can be bigger, faster, and more computationally intensive. And the two ways that rollups are secured to layer 1 is with proofs. So one of them being fraud proofs for optimistic rollups, the other being zero-knowledge proofs, which verify the state at basically every time it rolls up. So both of those mechanisms are ways of securing the layer 2's transactions to layer 1, which is, I think, quite important. An important distinction to sidechains, which are not rollups. So transactions likewise can be large, bigger, faster, computationally intensive, but they do not secure the state to layer 1. So something like Polygon gets confused with being a rollup, or some people confuse it as a sidechain rollup or a rollup sidechain. But really, it's only committing some of the data to Ethereum, but actually it's not having any proof mechanisms for other people to verify it necessarily. So then, with that as the foundation, to say, okay, here is layer 1, layer 2. We want that to be usable. We want to see what's possible for what applications. So this is just an indicative chart to say when you have the cost of transactions at L1 levels, where they can be quite expensive. And so the curve would look something like that. The cheaper the transactions, the greater number of viable applications there can be. And that's what I think we really should be looking at. On top of that, if you improve usability, you'll get more users and more impact. So those applications that are built at the different sort of price points, if you will have different, can get more users if it's easier to use. So the types of applications we see at the sort of expensive level are hyped up NFT drops or high value asset transfers, traders moving large amounts of money. It's worth their while to be spending on layer 1 Ethereum because they've got a lot at stake, they're moving a large amount of money, making a lot, so they'll spend that $100 on a gas fee because it's worth it for them. But for most people, that's not the case. So layer 2s make transactions that much cheaper so that things like casual gaming can afford to pay some cents or under like maybe $1 or so for a transaction. It's worth its while for games to do those kind of in-game assets and transact them at $1 a transaction. But what we really want to do is target here. The only way to get, say, microfinance for developing economies is if transactions are sort of sub-cent. I'm not saying we're there yet with the project I'm working on, but there are some other EIPs that come into play that will bring it to that point, I believe. So that's what we really want to aim for. We want to really explode the amount of viable applications that can be built and secured on layer 1 Ethereum, not just a faster, smaller blockchain. So I'll dive a little bit into the tech, but in a nutshell, when you make transactions to layer 2, you have the transaction data as well as the signature. So every transaction is signed by an individual signature. That gets verified on the layer 2 and then rolled up to layer 1. So the data for every transaction as well as every signature is submitted to layer 1, and that's got a cost associated with it. With the project I'm working on, we use a BLS signature scheme with on-chain verification so that we can reduce the signatures. So rather than having n signatures for n transactions, so if we had 200 transactions, we'd only be storing one signature, not 200 signatures. So that's actually a very large saving with what gets written to layer 1. So transactions just, again, become that much cheaper, cheaper than layer 2. This is roughly the architecture we have. We're building a client module that will go inside wallets. We have a prototype wallet that's just an extension. We have our own dedicated aggregator that will combine the signatures of a set of transactions. And there's the smart contracts, which have a verification gateway and a smart contract wallet. In the future, the idea is that this client module will be in other wallets, so other people are using this in a more convenient way. The aggregation code will be in layer 2 nodes, so we've already been approached by one of the layer 2s who want to do that. We've been approached by some wallets who want to integrate this component. And basically, this fits the standard of EIP 4337. Just as a high level, this is the group within the Ethereum Foundation that focuses on these projects. One of them, the project I'm on, is called BLS Wallet, but there are a lot of ZK zero-knowledge projects as well. So I didn't quite appreciate how much people actually valued this because it's all funded by the Ethereum Foundation, all open source, can be used by anyone. So it's, someone who discovered this said, oh, wow, this is just free. Oh, I can just use it. So it really powers up applications and gives them a lot of, basically lowering the technical entry barrier for what solutions they can create. So I thought I'd share that one. That's what we work on. So a little bit about the merge. What I appreciate about it, again, I'm not working on the merge. I'm not so close to the core team or anything, but I do know some people working on it, both within Ethereum Foundation and outside of it, in Australia as well. They're independent companies. They've got a shared technical specification, And yeah, they've just got a common goal to improve Ethereum. So they're all able to do that, and I thought it was quite impressive how it came together. So yeah, this is now, I can talk about it in past tense. The merge happened. Hooray, it worked. But yeah, the beacon chain has been around for a long time, running in parallel. This is sort of, yeah, beacon chain's running for a while, the merge has happened, and what's coming next is sharding. So that's, yeah, I was going to go a bit more into that. But yeah, that's just from the site, ethereum.org, because again, I'm not on the core team. But yeah, the merge represents the joining of the existing execution layer of Ethereum with its new proof-of-stake consensus layer, the beacon chain. It eliminates the need for energy-intensive mining and instead secures the network using staked ETH, a truly exciting step in realizing the Ethereum vision, more scalability, security, and sustainability. So again, just from the website, but I just thought that's nice. But I'm going to pass over to Dankrad Feist, who, yeah, maybe I'll let you introduce yourself.
Sure. Yeah, hi, I'm Dankrad. I work on the research team at the Ethereum Foundation. And I'm going to very quickly talk a little bit more about that merge and the new staking algorithm, or the proof-of-stake algorithm, that Ethereum just transitioned to. So the Ethereum POS algorithm, the consensus algorithm, is special in several ways and is different from what you see on most other blockchains. And so one of the fundamental distinctions is that we don't actually have just a single algorithm. They're actually two different ones. One of them is called Ghost, and the other one Casper FFG. And so the reason we're doing this, so Ghost is very similar to, in a way, to how proof of work chains work. It just builds a chain, and the valid chain is basically, in a way, the longest chain that is being built. What it does is it can always build a chain no matter how many validators are online. So even if like it's World War III and half of the world is in cinders, it can still work, it can still build a chain. But of course, what that means is there could also be several different chains. So it doesn't have like absolute security, but it always builds a ledger. Now Casper FFG is the finalization algorithm. And this one only works if at least 2/3 of the stake is online. And basically, once Casper FFG has gone over a block, then it can never be reverted unless at least 1/3 of the validators equivocate, and then they can be slashed. But of course, this has a downside that it can only work if 2/3 are online. So if like some catastrophic events happens, then you might not have finalization. And finalization takes about 12 to 18 minutes after a block is first being built. And visible in the Ghost part of the chain. And here's how you can imagine this little picture. So basically you have this available ledger that's kind of racing ahead, that's built by the Ghost algorithm, and then behind that you have a finalized ledger that can never be reverted. Yeah, so this is kind of special, and like, yeah, we're doing this for several reasons. One is obviously that it means that we can always progress even in very bad circumstances. And the second one that is also important is that Ethereum is also very special in how many validators we can support. Like, if you look at most other chains, they support maybe a few hundred, maybe 1,000 validators at most, and Ethereum is right now already running with about 400,000 validators. And that's also enabled by this architecture. The second interesting aspect I want to talk about, I'll come to in a minute, but let's first talk a little bit about decentralization. So often, like, decentralization which is our goal, is talked in just like how many different entities make up the network. But there are also actually many other aspects, and I want to go a little bit about these. So for example, we can also talk about the infrastructure and the software they're using. So for example, are they all running the same client? That's a form of centralization. Or are they all running the same operating system? Even that is a form of centralization. And then we can talk about the physical infrastructure they use, such as the internet service providers and the power grid. And in an ideal world, we want all that to be decentralized, because all of these are potential single points of failures. If your client has a bug, then that might bring the whole network down. Or if like the power grid goes down and everyone is running on that, like in the same region, then that can also bring the whole network down, and we don't want that. So what we want, ideally, is that each of these factors, any centralization is under 1/3. So basically, ideally, we want that at most 1/3 run the same client, and at most 1/3 will run on the same operating system, and so on, for each of these factors. And if that happens, then that means that any single point of failure can never lead, like any sort of power outage that only affects one region, for example, cannot cause the Ethereum network to go down. But how do we achieve this? So it's difficult to punish people directly for example, for running the same client software, because they can just lie about it. Like, there's no way to objectively check which client you run. So, like, if you want to run one client, but there are incentives to run a different one, then, yeah, you can lie about it, and there's nothing we can do about it. The only thing we can do is we can punish when this leads to failures. And the way that this works is through so-called anti-correlation penalties. And so the way it works in Ethereum is basically if you get slashed in Ethereum, if you make a mistake, usually the penalty is actually very small. And you can see it on this graph. If you get slashed and nobody else gets slashed at the same time, you lose about 0.5% or so of your stake. So that's a punishment, but like more like a slap on the fingers. But it goes up, and the way it goes up is depending on the percentage of validators that are slashed at the same time. And same time means within like a few weeks or months of you getting slashed. And basically, so the current penalty is the blue line, but the red one is the ultimate one that will be implemented long term. And basically, this line rises linearly and reaches 100% at 33%, so 1/3. So exactly when a failure could lead to like actually catastrophic consequences on the network, then you will actually lose your whole stake instead of just a very small percentage. And so this disincentivizes running the same client as everyone else, for example, because if your client has a bug that leads to you getting slashed, then if you are running a small minority client, you'll actually be fine, because there will be very few other clients that get slashed. But if you're running a client that's running, say, 1/3 of the network, then you'll lose your whole stake. So this is a strong incentive, like, to think about, well, what about running a different client? This curve is for when you introduce basically something invalid into the chain. That's called slashing. There's a similar penalty that happens when you go offline for a long time. I won't explain this graph in detail, but it works similarly. So basically, in short, anti-correlation penalties are a way to create incentives for stakers to be uncorrelated with other stakers. So basically, what we want is try to run not the majority client, run a non-mainstream operating system, and also ideally be in a different location to everyone else. And that way you will be safer. Cool. I'll give it back to James.
Thanks for that detail. Yeah, so like I said, lots of smart people working on these things. I'm just sort of at a different place. I'm just going to quickly skim through these. I've only got a couple of minutes. But yeah, some highlights that you may have heard of, that the issuance has been reduced from 4.3% to, 0.43%. Yeah, this is just a detail around how much you invest in mining effectively. So if you're, with proof of stake, if you're staking an amount, or if someone else stakes 10 times that, the rewards are still like proportionate to 5%. Like, it's a proportionate reward no matter how much you're sort of staking. With proof of work, it was a little different. Like, if you spent a lot on hardware, infrastructure, or ASICs, and you were beating others, it would be greater than the proportion of what you spent. So someone with a small rig at home kind of loses hope after a while, and they can't really keep up with the big miners out there. The block time was slightly reduced from 13.6 seconds to 12 seconds, but that only has a small increase in capacity, so it's processing more transactions over time, but really the primary amount of scaling comes through rollups. But of course, the main win was, or one of the main wins was in energy consumption. So this was an interesting graph, again, from ethereum.org. I didn't place it there. But you've got YouTube, the mining of gold, Bitcoin's proof of work, and then Ethereum proof of work is here. And now this is Ethereum proof of stake. So it's really reduced, but still lets us see, like, you know, where else are we spending energy on our servers. So just to summarize, really with further optimizations, with reducing transaction costs, we're going to see more viable applications being built, and that's really what we want to see on top of this wonderful decentralized infrastructure. And that's sort of my interest, is to try get more people looking at the products that are potentially outside of DeFi and trying to explore that. So I'm starting a sort of product design-a-thon. It's to get non-technical people to really look at problems that exist and attempt to see what solutions make sense that use Web3, as opposed to going the other way around and building a Web3 product. I always say products and Web3. So the idea is you're not just going to get an NFT idea and then slap it onto anything you can find. You're going to look at a problem and say, you know what, how do I solve this problem? Is there a Web3 component that actually solves that problem in a meaningful way? Because this is, I would say, an underserved area in terms of exploration outside of DeFi. So that's what I'm doing. So if you're here, yeah, that's what I'm doing. So yeah, there are so many viable applications beyond DeFi that are being unlocked. And then, yeah, now is the time to discover them.